Awesome. So we're starting about 10 minutes behind today. Let me go ahead and share the entire screen and not just that particular page so we can see everything correctly. Okay. So today we're looking at, again, welcome. Today we're looking at session 9, which talks about open mic. All right. So here is just for you to give me your questions. We'll discuss about what's going on in the recent trend of events in IT. A quick recap on what we looked at previously. We started off in June and things changed a little bit. There was an interruption. So we switched the dates and we started off again in October with cloud computing. Last week, we talked about software programming. Every session is recorded. And we have the recordings on YouTube for you to use as a reference or, revision for one reason or another. Today we're going to talk, we were supposed to talk about, mobile power on the go, but I figured it would be better for us to have an open mic. Let's say you have any questions concerning what we have talked about before. We talked about introduction, some kind of history of computer science, about Facebook, Amazon, Microsoft, Google, and Apple, their history and how it all got started. I introduced to you some IT career paths, the 10 main branches with respect to the labor and the labor statistics that are pulled in the United States. We went down to the nitty-gritty, the very basics of hardware and software. Then we talked about the internet and the web. We went ahead and talked about cybersecurity as well as databases before revisiting everything we talked about. So that said, my goal today is to be able to talk to you about some common IT terms, especially the ones that are really confused, basic things that you need to know, and then some emerging IT trends in the field, so that by the end of the day, you should be able to understand clearly what is what. So that said, let me look at the breakdown of my plan today was, let's look at this tab. So take about 20 minutes to talk about the confused IT terms, and then another 20 minutes to talk about common IT terms, as well as giving the mic open for you to ask questions so we can discuss on anything that we need to talk about. Sounds good? Everybody with me? Or everybody's silent?
Yes. We are here. We are with
Okay.
you.
Any questions? What questions do you have so far before we get started?
We wait for open mic.
Okay, good. So let's get started then. There are a few notes that I have in here. You can always go into our Google Classroom and check out the notes that we have. And oops, I keep going back. Let's go in here. Must have deleted it. That's not bad. Yeah, that's it. Anyway, let's jump in here. What are some of the confused IT terms that we talk about? The first one I would like us to visit is, I tried to put them in alphabetical order, but I failed horribly. So there are a few terms you hear about 5G and 5 gigahertz. There's a main difference between the two of them, okay? 5G has to do with the new, generation of how can I put it, networks, right? We had the 3G, the third generation, fourth generation. This is the fifth generation, so networks are going to be a lot faster with 5G, obviously, if they're using 5 gigahertz. So if you have Wi-Fi at home or in an office, you can set up your Wi-Fi to run at a different frequency. 5 gigahertz has to do with the frequency. Okay, let's say 5G frequency in terms of Wi-Fi, but 5G has to do with the generation. So the generation of networks could be using that 5 gigahertz or not. So it's easy for you to get confused with those two, but that's something very basic that I wanted to point out. The next two things we want to discuss is disk with a K and disk with a C. You know, there's a very big difference in computer language, in computer science, not in English. English, it might be interchangeable, it might be United States English versus British English. But in computer science, when you talk about a disk with a C, it refers to an optical media. Think about CD, right? CD-ROM, compact disc. Okay, you can insert it into a computer, you can remove it. But when you talk about a disk with a K, that's talking about, think about hard disk, hard drive, HDD, which stands for hard drive. So disk with a K would be HDD, hard drive disk, as disk with a C would be CD, okay, which could be CD-ROM and so on and so forth. Sounds good?
Yes.
Awesome. Now, let me give it to you guys. What do you think would be the difference between memory and storage? Anybody likes to share? Come on. It's okay to go ahead, and everybody's on mute, by the way. So you can unmute yourself and speak up.
I think I have an idea of memory and storage.
Go for it.
I think that memory is permeable, it's permanent, that it remains the same, but storage, I think, may alter.
Very good attempt. Very, very good attempt. So, but I think you might have switched it around. Okay, memory and storage. Now let's take a look at this. What is memory? Think about your computer. If you open it, you can put in memory, you can expand the memory and so on and so forth. Memory is volatile. Memory is not permanent. Memory, you only use it in a certain short period of time and you can access it really fast. So if your computer has a lot of high memory, then it's going to run faster. Storage is the one that is the capacity of your computer. So how many files can you have? How many programs can you save, right? You can access it very slowly, but that is what the storage is. So normally when you want to buy a computer, they'll tell you what's the capacity. It's talking about, is it 250 gigabytes? You know, that's the amount of space that you can store. Your memory is not going to, your storage is not going to fall short or run out. Then memory is what you use to run your program. Okay, so if you have low memory and high storage, your computer is still going to be slow. But if you have high memory and low storage, you don't need to store a lot of stuff on your computer, but it's going to run a lot faster. So again, if you look at it, you know, memory is where application loads its data for it to be processed. But storage is where you actually store all your data, whether it's a database of files or programs, and it's permanent compared to memory, which is temporary. So memory is always going to be smaller in size, storage is bigger in size. You know, sometimes you might have an external hard drive. That external hard drive is for storage. You know, you don't really have external memory, you know, because memory, you can access it very fast, and storage, it's going to be a lot slow. But normally, if you want to call it, you know, it's normally known as primary memory, and storage is known as secondary memory, because storage, you can actually remove it if you need to. Does that make sense?
Yes.
Awesome. The next thing is viruses and malware. I know we talked about this when we discussed about cybersecurity, right? Cybersecurity, we did talk about viruses and malware. Does anybody remember?
I think I have an idea.
Go for it.
I think a virus is a malware that attacks a computer and destroy information inside icons. But malware is a general name for virus, all those malicious way. I think it's a general name for it.
That is very excellent. Malware, as it says, is short for malicious software. Again, we are going to talk about software when we get to application and programs. Virus is a particular type of malware. So virus is a subset. The virus, again, only works if a human interaction is taking place, either by you clicking a link or by you going to a website or by you downloading some stuff that you're not supposed to download or by you opening an email. That's how you get a virus. If you don't do anything, if you don't take a particular action, you're not going to get that virus. So in a nutshell, a virus is a subset of a malware, okay? And if you look at malwares, there are many different types of malware. I think I should reduce this size here. There are many different types of malware. You can have ransomware, where they'll encrypt your data and tell you to pay money before they can give you back. You can have worms that just replicate themselves within the system. You can have Trojans, malicious software that's going to disguise into something else, and so on and so forth. Adware, cryptojackers, botnets, rootkit, spyware, we talked about those. And I encourage you to go back to those videos that we talked about. I think that was session number 5. If you go to cybersecurity fundamentals, everything in there was covered, okay? So it will be a good review for you. So that would be the difference between viruses and malware. Now, how about internet and World Wide Web? Beatrice, are you there? I'm going to put you on the spot. I think you're on mute. Okay, I think you're still on mute. Okay, Del P, I'm going to put you then on the spot. You'll be the next person. What do you think will be the difference between the internet and the web?
I think I have another idea, just an idea.
Okay, go for it.
I'll try. I think the web provide internet services, while internet is a worldwide infrastructure, a worldwide communication network that connects computer. I think that's the difference.
Good, you got that really close. Does anybody have anything else to add? So internet, again, is interconnection, right, of networks. When you're in an office, the computers are connected together. When you're at home, your cell phone is connected to the Wi-Fi that your computer is connected to. And if you have a smart TV, the TV is also connected to the Wi-Fi. That's your network, right? Your network at home is connected to the network of your neighbor, because the neighbor is probably using the same ISP, what is known as Internet Service Provider. Okay, so let me write that in here. So you have an ISP, Internet Service Provider. It could be Camtel, that's providing internet for everybody in your neighborhood, or it could be Verizon or AT&T, some global other network infrastructure or network company. And when you combine your network and your neighbor's network and the network of the whole city and the neighboring city and the other country, you come up with the internet, because it's the interconnection of networks across the entire world. But the World Wide Web has to do with websites, okay? Your website is connected to another website, or your web page is connected to another web page, which is connected to another web page. All of these web pages form what is known as the World Wide Web, okay? So I try to make it visual so that we can understand it, okay? So internet, again, is global system of interconnected computer networks. Okay, we're not going to go to the technical details of how it uses TCP/IP protocol to link the devices, because we talked about that when we talked about internet and World Wide Web. But online content, which is usually written in HTML to create a web page, when you connect all those contents, that's when you have the World Wide Web, okay? So technically, the World Wide Web is part of the internet. because the internet also contains other things like email, which uses SMTP, Simple Mail Transfer Protocol. It also contains voice over IP, okay? It also contains FTP, which is File Transfer Protocol. So all of those make up what is known as the internet, amongst many other things, but the World Wide Web is just a website. Does that make sense? Sounds good. The next is an application and a program. Okay. Now an application, a short word or a common way we call it is an app. What is an app and what's a program? There's another word that also gets confused in there is a software. Okay. Because if the person that's developing this could be a programmer or an application developer or a software developer, some people use it interchangeably, but it's really different, okay? You have also on a computer what is known as an operating system. We talked about this when we talked about hardware and software. Okay, hardware are all the things we can touch, keyboard, mouse, speaker, microphone, and so on. Software can be divided into what you have as operating system, drivers, and then all these other applications that we see. So a program is something that can run on its own, a standalone, like a driver, a program runs your computer, but an application is something that depends on a program. So how can I put it in other words? Okay. A program is just a collection of instructions that you execute on that hardware. But application are programs that are designed for you, the end user, to use. The things that you click, you drag and drop and so on, okay? So without computers, programs cannot really work. The computer will not be able to do anything unless you have just the operating system, okay? So an application, again, is a subset of programs. There are different types of programs. Applications are just one type of it, okay? But applications are important because they allow the customer to do a particular thing, maybe a service or a product. For instance, your web browser. Your web browser, just like Chrome or Internet Explorer, it allows you to go to the internet, to go to the website. Meanwhile, the program actually runs that browser, okay? I can have another application, which is maybe Outlook or Gmail, which helps you to be able to send email. It does that particular service for you. So that will be the difference between an application and a program. Does that make any sense? Okay. Good.
Yes.
Next up, I'm sure you guys are pretty good with this one, browsers and search engines. Okay, browsers and search engines, again, a browser could also be known as a web browser per se. You use a browser to be able to go to the internet, but sometimes you tell somebody like, what web browser do you use? They'll tell you Google. That will be incorrect, okay? Web browsers would be, for instance, Chrome, which is from Google. You have Firefox, which is by Mozilla. You have Edge, which is taking over what was formerly known as Internet Explorer from Microsoft, obviously. And we have Safari, from Apple. There are a lot of other ones, small ones. There's Opera, there's also Brave, which I learned about, and so on and so forth. So these are all different types of browsers. Search engine, again, is something that helps you find information on the internet. Search engines, examples, obviously everybody's familiar with Google, which is the most popular one. You also have Bing, and so on and so forth. There are multiple search engines out there. There's another called DuckDuckGo, which uses privacy and so on and so forth. Okay, so does that clarify the difference between a web browser and a search engine? Everybody good with that, right?
Yes.
And we also talked about bits and bytes. We talked about it a lot actually last class, but I'm going to use this opportunity to shed more light on it because I know most people did not make it to the last class. But in computer science, right, let's actually just look at this. Okay, this is a CPU. What exactly is a CPU? A CPU is a bunch of transistors. When I say a bunch, it's actually millions and billions of transistors that have been compressed together. Okay, so for one transistor, I'll probably have to use a different page here. For one transistor, right, you could either have an on or an off switch, meaning electricity is either going through or electricity is not going through. All right. So that is for one transistor. Now, if you end up having one transistor in your CPU, that means you can have two values present. But if you go ahead and expand your transistors to be two, then you can have four values because you can have either both of them. Sorry, not four values, I'm sorry. You can have double the amount. So you can have either one being on and off. Let's see, I need to try to switch this over. Oh, wow. Let's do it that way. So one, you can have either on, off, and there you go. So now this is two, it could be either on and off and on, and let's see, let me put it this way. With one transistor, you can have two values. With two transistors, you have four values. With three transistors, you can have 8 values. When you get to 4, you can have 32 and so on and so forth. Okay, that's how it increases because of the fact that you can either have electricity going through or not. Now, in order to represent this in computer science, we actually use what is known as, they use 8 different transistors. So if you use 8, this would be equal to the exponent. Oops, let me say power. Two raised to the power 8. 256 different values that you can have if you have 8 transistors. So in that case, you can have it written in the format of one. I should go to another tab here. Let's do this one. I just want to make it a lot smaller so that we can look at it side by side. Okay, so you can have 1, 2, 3, 4, 5, 6, 7, and 8. So when you have all of these 8 transistors being used to pass in information, you can pass up to 256 bits of data. Each of these is known as either 0 bit, meaning the absence of electricity, or 1, which means the presence of electricity. This is being used in what we know as a binary notation. Binary meaning 2, so it's either a 1 or a 0. So the idea of having a bit is short form for binary digit, okay, which is what makes up a bit. But then when you have 8 of them together, it becomes a byte. So a byte is equal to 8 bits. So when you say your memory or your computer, the CPU, uses up to 256 bytes or 251 bytes rather, let's say 1 byte would be equal to 8 bits. So when you say you have 1 gigabyte of data, then you're talking about millions, I think, million of these ones and zeros that you can actually pass through your CPU in every single second. So it depends now on the speed. So you can go ahead and see 1 gigabyte, oops. Let's see. Yeah, that's 10 to the power 9, I believe. But if you look at the breakdown, it gives you a structure of all of those per se. 1 bit again, just 1 or 0. But 1 byte is 8 bits. 1 gigabyte is 1024 megabytes. But then what is a megabyte? A megabyte is about 1,000 kilobytes, and a kilobyte is about 1,000 bytes. So that gives you an idea of the capacity, how many is within a particular gigabyte. Okay, so going back to our initial discussion, what is a bit and what is a byte? A bit is a binary digit, which is actually a 0 or a 1. A byte is 8 bits put together. So data is usually stored in bytes, and these are all measurements of data in terms of storage, or in some cases, you could use this as speed. When you say how many bits can you transfer in a second, or how many bits can you transfer in a minute. Does that make sense?
Yes, sir.
Sounds good. Okay. Next up is WAM and WOM. You know, we've talked about this very, all over the place so far anyway, but WAM, again, as you see here, is these are all different types of memory. RAM is random access memory. So you can access it really quickly and you can access it randomly, but again, it's very volatile. It doesn't stay. The moment you turn off your computer, the memory or whatever data that was inside here evaporates. That's why it's volatile. So if you're typing and your computer goes off because the battery is dead or one reason or another, you cannot get that information back because it was stored in the RAM. But the RAM is read-only memory. Think about CD-ROM, for instance. Even if your computer goes off or comes back, if you have a CD with movies in there or a CD with audio, music in there, the music is still going to stay on the device or on the apparatus, whether there's electricity or not. Whenever you come back, you still have your data on there. Does that make sense? So that said, now we go to 32 bits and 64 bits. That is very similar to what we were discussing earlier, the bytes and the bits, okay? The platforms that we use, the systems that we use, they can either be transferring information. Think about, again, 32 bits, that will mean, you can have up to, think about it as you have 32 different lanes of on your road, and you can have 32 cars going in one direction at one time. But then when you talk about 64 bits, then you can transfer 64 bits in a particular second, for instance. So obviously, you'll be able to transmit more data. It's going to work faster. Back in the days, memory and storage were very difficult to come by. It's not like right now where you can have a small flash drive that can take up to 10 gigabytes or 32 gigabytes and so on, 64 gigabytes sometimes. These tiny little cards that we put in our cell phones or in other devices, they can hold as much as possible because of the different, the way technology has changed per se. But before, computers were all 32-bit. Those were all 32-bit systems because they could be able to transfer information 32 in 32 bits. Why do I say that? Normally you can have 8 bits in 1 byte. So normally you'd have 8 4 times to be able to transfer data. Okay, so it was like 4 lanes of data being fed in each instance, but now it was expanded in recent times, most of your information, most of your software, your operating systems are 64-bit. Right now, if you have software that you have developed software or applications, as we discussed earlier, that uses this 64-bit system, you cannot run it on the old computers. That's why if you have, let's say, those old devices that were created in the 90s or the 80s, you cannot run all this new software that are created in these days because it's not compatible. What is built for 64-bit cannot be handled by what is built for 32-bit. So think about having a big car that, it's supposed to take all the 32, or should I say 64 lanes. It's not going to be able to drive in this 32-bit space. But in some cases, the 32-bit platforms or systems could still run, or the 32-bit programs, those olden day programs that we've created, they could still run on the 64-bit, depending on if the services and everything is still there. But sometimes people will still want to buy computers that are 32-bit because maybe they have some old systems that they are using. Think about government institutions. They don't want to upgrade things for one reason or another, maybe for security reasons. Then they will still need those 32-bit systems and those 32-bit programs to be able to use their old servers and old computers to work. Does that sound good? So that would be the main difference. That would be yes. Did somebody have something to add? Just make sure you unmute yourself if you have to speak up. Otherwise, we might be missing your discussion because everyone is still on mute. So those are the main things that I wanted to point out, some of those differences and those terms that get confusing. There are a lot more of them out there, but these ones are some basic things that if you find yourself in an interview, if I were to interview a candidate for a position, these are some of the basic questions that I can always ask them to understand if they know the fundamentals in IT. If you come in and, you tell me more about you, how did you learn about this position? And then I can throw a curveball at you and say, hey, what do you think is the difference between a memory and a storage? And, it might not have anything to do with your business or the job application that you're applying for, but it's going to make me understand, hey, this is how knowledgeable you are, these fundamentals. If someone were to ask you what's the difference between a bit and a byte, then you remember that a bit is a binary digit, which is either a 0 or a 1, but a byte is made up of 8 bits. Then, the person knows, okay, your basic stuff. You really know computer science or information technology, okay? Because those are the standard things that you need to know. Sounds good?
Yes.
All right, so we've talked a little bit about, where are we? We've talked a little bit about those confusing terms. It's time for us to carry on and talk about some common trends in IT before I open the floor for everybody to ask whatever questions you have. So if we look at some terms that are trending, okay, there are a good number of them. I try to put them into particular categories, but I also have a text file here with all the information. If you need to get this, you can always get that from, you can always get it from, oops, not that you open it, from our Google Classroom, okay? So if you go to the Google Classroom, you should be able to see all the content that is in there. Yeah. So that said, let's jump in and talk about a few of them. I did list them out. Did I not? I thought I did. Never mind, I did not. No, I did not list them out. That's not good. All right, so let's look at a few of them. Adaptive technology. What is adaptive technology per se? Okay. Adaptive technology is a subset of what is known as assistive technology. So let's go into that a little bit and talk about it. So assistive technology, you know, we have certain people that have disabilities, okay? Some people that cannot see colors correctly, some people that have difficulty hearing, some people that have difficulty, you know, reading and so on. So assistive technology is any system or product that we use to help the capabilities of these people with disabilities, okay? So it can be something that, you know, is bought off the shelf or is modified. For instance, if you see on a website, any website that has images, each image usually has a description to that image. So that if the person that is looking at the website is a blind person, because blind people do look at websites, you know, they can use what is known as a page reader, right? So it goes in there, it reads, it does a text to speech for them. It reads out the text. When it gets to the image, it will tell them this is an image of a soccer football, or this is an image of a pic of a car, because you're using that. Now, what is adaptive technology? Adaptive equipment or adaptive technology has to do with a subcategory of that, okay? So looking at that, adaptive technology is those tools and products that are created to help people with disabilities in order for them to work productively and efficiently, all right? The next thing I wanted us to talk about is agile technology. Last class, we talked about software development, software programming. And we said in software programming, we usually start by gathering requirements, designing the software, implementing it, testing it, and then we keep the maintenance. Back in the days, that is the waterfall approach that was being used to develop a product. So if you want to build the software, that is the approach that was done. But in recent times, you know, agile methodology or agile technology developed so that instead of trying to build a car from start to finish before doing the testing and maintenance, you start by building a particular feature of the car. So you can start and say, I'm going to build the tires. So in your backlog, you have the items that you need to build in order for the car to work, because the business has come to you and said, I need you to build me a car. The car should have 3 tires. It should have a steering wheel. It should have 2 doors, or it should have 4 doors. It should have a radio. It should have a steering. It should be blue color and so on. You start and go into the backlog and say, okay, I want to build the tires. You go ahead, do your analysis, define the terms, design it. Once you've done designing the tires, you test it, you deploy it. The tires are set. Now you know tires are working. You go back to your backlog and you start building the cabin, building the doors and so on. So you build them one feature at a time. Instead of building everything together and then testing it, you realize that, oops, I ended up with 3 tires instead of 4 tires. So based on the idea that you have your requirements that you have gathered in your backlog, the requirement says 4 tires, you build your 4 tires, you test, it's done. You build the next one, you integrate it and so on. So that is what agile is all about, okay? So what is agile again? It's a set of processes for creating software that includes being creative and flexible, okay? So it means that you do it as simple as possible, you test it often, and instead of waiting for everything to finish, you do it by increments. Increments, also known as iterations. You can do one iteration now, you do the next iteration of each of these parts that are functioning. And then once you release it, you test it, and then you test everything together, and then your work makes it a lot easier. Does that sound good?
Yes.
All right, so that's what agile development is. There are different types of agile development, which I don't want us to go into. It could be Kanban, Scrum, and so on and so forth. But when somebody says, I want to learn Scrum, I want to become a Scrum Master, I want to get agile, they're helping all these companies that used to do things the old way to start doing it the new way, and also maintaining it, because you don't only have to do it, you have to continuously doing that, okay? All right, that said, let's go into the next one. Where was I? Training terms. So we've talked about adaptive technology. We've talked about agile development. The next one is big data. What is your understanding of big data? Let's go back again to the drawing board, okay? Way back when, computers started in the 1980s, we had analog data that was being generated and digital data. It was just about 1% of the data was digital. And then you started having, audio tapes, disk, and so on and so forth. It started increasing to about 3% in 93. By the year 2000, analog storage had reached its highest size and digital storage was exploding, okay? All the way to 25%. By 2022 was what is known as the digital age. If you look at, 5 years later on, the amount of analog data had reduced so much, very few paper and other analog tapes. Most of everything was digital, digital, digital. Today, if you look at the world, most of our information is definitely digital. But what does this have to do with big data? Big data, again, is a collection of all these various sources, which has been characterized. It started by being characterized into 3 V's, okay, which has to do with the volume, the amount of data from all these different sources. And then the variety of the data. Some of the data is structured, others is semi-structured. Another set is not even structured at all. And then you see the speed at which you're generating this data. Just in one day, the amount of data that can be produced in one day is more than the amount of data that was produced in 10 years in the 90s or in the 80s. Because look at Facebook, look at Twitter, look at Instagram, Yahoo, Gmail, whether it's emails or it's videos on YouTube and or whatnot, that's the amount of data that's being generated over time, okay? Now, as time kept going, more V's were being added to the description of big data, because now you have to also check, is this data true? Is it trusted? Because anybody can go out there, I can go on the internet and say, the president of America is Vitus, the president of Cameroon is Peter. That doesn't make it true. So now you have to be able to analyze this data, the myriad of data, for its veracity. Okay. And now you also have to check on the value. Or is this data valuable to my business? If so, maybe I should collect it. If it's not valuable for my business, I don't need anything to do with it. Okay. And then how does it vary? The ways in which, it can be used or formatted and so on. But there are a lot more fees that are being added into big data every time, as we keep changing in time per se. So it's not just about the volume, value, and veracity. We've talked about visualization, variety, velocity, viscosity, and so on and so forth. So that is what big data is all about. In a nutshell, if we want to describe it, it describes the phenomenon of the growth, use, accessibility of information. Okay, it comes from these different sources that we've talked about. And so it could be structured, semi-structured, unstructured, and it could, be a rise in new tools to analyze the data that is available to you. Okay, so that is what big data is all about. Why is it important? Okay, it's important because the size and complexity of the data, it's not possible to understand it using the old ways that we use to analyze data. So you cannot ignore this data. It will be a mistake for your organization, because maybe this data was valuable for you to be able to project things in the future and so on and so forth. Think about these elections that keep taking place. People have to check the data. You see maybe the census data, the number of people in a particular area that's going to vote. So you know how you have to reach these people and so on and so forth. Gather information about the people, what they like, what they do not like, what their interests are, and so on and so forth. So all those things are what make up the big data. All right. More information. Let's talk about businesses per se. What is business intelligence? Most of this terminology, as I'm going to compare it with human. So what is human intelligence? Business intelligence will have something to do similar to human intelligence. So business intelligence, we have to think about data again. I know we talked about databases. So definition of business intelligence is concepts and methods created to improve your business decisions. Okay, and you make these decisions based on facts that is supported by your systems that you do. So how do you start with this? You start by gathering data sources. We just talked about big data. After you've gathered all this data, you use data warehouse to do what is known as ETL. You extract the data, you transform it into the format that you need, and then you load it into your databases, okay? After you've done that, you do your data mining to be able to analyze that data and then report it. When that report is sent, thinking about the example we just talked about, demographics, the age, the sex, the different features of humans within a particular area, you can say, okay, based on this reporting, there are 60% of women in this area, and there's 40% of men. Out of this 60% of women, 80% of them are going to vote. Out of the 40% of men, maybe just 2% of them would like to vote. So you know how to target that market. Based on that, you can make a decision like maybe our advertisement should have a lot of women in there. Maybe our message should be targeted towards this kind of people. So your business intelligence is being able to gather all this data, transforming it to be able to make business decisions that whatever business you are in, it doesn't have to be elections, it could be other things, okay? So how does it benefit us? It speeds up our decision making. We have key performance indicators are being, utilized or targeted per se. And, you can nail your competition. It increases your profits. There are so many other benefits in using business intelligence tools and processes to be able to target it. So these are all things that, in IT, it's trending today. You have people trying to become data scientists or data analysts because of things like this business intelligence, okay? So that said, next is BYOD. Does anybody know what BYOD is?
So can you come back with this business intelligence?
Yes, go for it.
I do not really get it. I do not understand. Business
Okay.
intelligence.
All right, so let's see. Let's say you're in the business of selling food, right? And you know that children like candy, sweets, and then older people like, I don't know, maybe they like rice. Let's put it that way. So now, in order for you to produce food, you need to be able to target your audience. Are you going to be selling mostly to older people or to younger people? So now you go in and gather data. Okay, you use tools, processes, and technology to be able to gather information about your audience, for instance, and then transforming this information to come up with analysis or reporting. Based on that report, you can say, okay, there's 10% of old people in the population, and there's 90% of young people. So there's no need for you to be making a lot of food for older people. You're going to be losing your business, right? That's how you build your business intelligence, like human intelligence. Human intelligence, when you wake up in the morning, you think that, hey, I have to be at work at 8 o'clock. It's 7 o'clock now. I have 1 hour to get ready. So because of that data that you have, that knowledge that you have, that work starts at 8 o'clock, the current time is this time, you can make a business or a smart human decision that whatever it is I have to do, I have to get ready in 1 hour to be at work. The same thing with the business. Based on that information that they have gathered, okay, they can go ahead and make a decision based on that. So let me go ahead and read out the definition, okay? Business intelligence then refers to the tools, the software. It could be Excel. It could be a report that is generated from Microsoft Access, or it could be a message that is sent from the IT team using an email. So you're using all these tools and software to analyze raw data, and it includes data mining, analysis, and reporting. So it allows you to cut the cost. You don't want to be making, investing in something that the audience or your customers do not want, okay? And you make better business decisions that way, okay? You even come up with new opportunities for your business, okay? But for us IT professionals, what is it important for us? It's important for us because we need to learn these tools. Is it, there's something known as Power BI. Okay, Power BI is an example of a tool. Excel is an example of a very popular tool that you can use to do projections, you can use to do analysis, basic analysis, and so on. Okay, so as IT professionals, you need these tools and software that you can come up with information for your business managers to be able to go ahead and say, okay, based on this report that you sent to me, you send this report and I can see that let's say this bar is greater than the other bar, so we should budget more money on making food for older people than making food for younger people, and so on and so forth. Does that clarify the question, the answer?
Yes.
VP, let me
Yes,
throw
I know.
more light maybe at where you are now, where your mouse is.
Yes.
I think at this point, it's like getting you, after you do the data mining, then you either show the result by whatsoever chart you can to reading, then making the decision. I think that's where she didn't really get it.
Okay, yeah, because
Yeah.
our own job, we are not the managers. We are, obviously.
So just showing your result by whatsoever chart you want to show, whether it's a bar chart or the pie chart.
Yes, yes. So
Yeah.
that's just one piece of it.
Yeah.
Our job could be maybe gathering this information. Our
Mhm.
job could be maybe doing the ETL part, extracting it, transforming it, and then loading it into the database. Or your job may be as a database administrator, cleaning up that database, making sure that everybody has the right tools and so on. And now you come up with that data mining, because if the data is dirty, your report is going to be wrong. If you're supposed to be gathering data for Kumba and you ended up gathering data for Douala, the report that you're giving your managers is report for Douala, and they're going to be doing things that they're supposed to be doing for Douala in Kumba. Then that will be wrong. So it has all of these pieces put together, okay, to be able to improve your care management. You're using data for better understanding of your business performance. Okay. So all that analytical insight, somebody has to learn how to do analysis. Somebody has to learn how to do visualization, reporting. Somebody has to learn how to extract, transform, and load the data or collect the data, and so on and so forth. So all of those are the things that make the IT experts or IT professionals be of real need, depending on whichever kind of business it is. It can be financial business, it can be education business. Should we, if you see, for instance, computer science has increased so exponentially where I am, for instance, that they don't even want students to even apply anymore. But now you start, let me actually do a quick search in here. University of Michigan, computer science trend, program trend. I think that was something that we're discussing earlier this week. Okay. And let's see, I should go to news. It's Michigan University. Okay, so this is an example of, information that has been gathered of, I think it's just giving me the whole full thing, but no, that's not what I wanted. It's not what I wanted. All right, let's see. I think I should do computer science. Because if I put CS, it's not giving me the full one. Yeah, I think that's what I was looking for. Acceptance rate. There you go. Okay. So where is it? It should be in news. It should be in the news. Come on, come on, come on. There you go. Okay, there you go. That's exactly what I was looking for. So if you look at the University of Michigan, okay, the computer science program is restricting admission starting this year because the demand has risen. You know, if you're being able to collect this information every time, you'd see that, you know, for the past decade, for instance, as is pointed out in here. So for a past decade or more, even maybe 15 years, there's a steady and very steep growth of student demand for computer science majors, okay? And they have been working hard to grow that capacity. So if you have been gathering information, let's go back to our tool. If you have been gathering this data and you see that in let's say 2010, you had 20 applicants. In 2011, you have 50. In 2012, it keeps increasing. That is going to show up in your report when you start comparing that, okay, this year was that amount and so on. And then you can also check out of this increase, is it mostly females or is it mostly Blacks? Is it mostly people from within the state or out of the state? Based on that, the managers can make a decision and say, you know what, we are having a lot of increase here. We don't need to be spending more money in other departments. We should spend more money to accommodate the demand that is for computer science classes. But now they haven't been able to do that. So now they have to restrict the growth of this enrollment. You know, it has quadrupled, about 4 times more, you know, compared to what was there before. If you look at the graph, it shows you the number of engineering degrees granted and number of LSA. I think LSA, I forgot what it stands for. I think it's literature, science, and arts, something like that. Okay. So comparing those two, you can see the rise in number of students, you know, from 109 all the way to about 5 times, 537. You know, you have to be able to use this information. This is an example of using that business intelligence to be able to adjust your business. You know, this is a education business per se, but it can work too for any other business. Does that make sense? Yes, no?
Yes. Yes.
Awesome. Oh my goodness.
So when you do the analysis, is the manager or whoever asked you to do such analysis to have a conclusion on the data you provide?
Exactly. The manager can then go, because the manager is going to sit with the CEO or owner or president and say, okay, these are our findings. You know, they're going to have monthly or quarterly or annual reports to say, okay, we're expecting so and so. You know, it's not only based on this admission, it could be also budget. How much money did you spend on this? You know, we had to spend a lot of time to, you know, in the past, let's go back to the graph. In 2010, imagine having 109 applicants. How much time do you take to go through this application? Now you have to use about 5 times that amount, which means you probably have to get 5 times the number of instructors, 5 times the number of administrators to be able to get your school to run appropriately. You know, if you have a school in Cameroon that is having 100 students in Form 1, and then the next admission you want 1,000 students, you have to be able to accommodate for that. The secretary is going to go crazy having to manage all those applications. So you need to admit more people, you need to put more money in there. Are you going to accept all 1,000? Are you going to adjust? You have to be able to adjust your business processes to adapt to that. Does that make sense? Okay. Yeah, I think you're still on mute. So yes, that's a good question so far, Beatrice, on that, but I'm glad that you did ask the question, and I hope it clarified it for everybody what business intelligence is. Again, by definition, it's concepts and methods that you've created to improve your business decision using facts or fact-based systems to support you, okay? Because this is a fact that the number has increased. Now you have to use that information and be able to improve your business decisions.
And VP, I
Yes,
think it doesn't really, let's use this school example. It
yes,
doesn't really mean that as we see the number of engineering students that are improved, then we have to improve the infrastructure. Also, in case, in the case that their tuition fees are lower than the other one, I think it's
yes.
there they have to also take a decision of reducing the number of the intake of engineering students. Now, depending on whosoever is taking that decision, because you might take a large number of them and they run on a deficit, they run on a loss.
Exactly, exactly.
Yeah.
So again, it has to do with all of those different teams. You know, you're
That's
getting
why you gather
feedback.
those data are there, the results is there, their cost, their what they gain at the end, all of them, all those things they matter.
Exactly, your income expense report and
Yeah,
so on and so forth. You know, based on your return of investment, is that something that you want to
yeah,
proceed with
because
or
in
you
the
want to do it?
engineering stuff, you need labs, you need laptops, you need equipment and so on.
Exactly,
But
exactly. Not only the
yeah,
personnel, but also
yeah,
the physical resources you need.
yeah. So you need to really make a good analysis and take a decision.
Good, 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 good. I just realized all along that my video was not even on. Sorry, guys. So let me go ahead and turn that on. Yeah, I just realized it wasn't even on. So yeah, let's go ahead and continue with where we were. I think we were talking about trending terms. We talked about business intelligence. The next one was BYOD. Yes, that was my question. Does anybody know what BYOD stands for? There's another one known as BYOB. That's bring your own beer. BYOD could mean bring your own drink, but BYOD means bring your own device. So
Device.
nowadays, you know, computers and other devices are being accepted in different companies. You know, you can bring your own device from home and use it at work. Before you just come to work and you use the computers at work. But there are many benefits. Obviously, there are also drawbacks of using this. But let's take a look at this a little bit. So what do I mean by devices? Most people would think it's just a computer. The device could be many different things. You know, it could be somebody bringing their own calculator or bringing their phone, bringing their own mouse from their house or their own keyboard and so on and so forth. So bringing your own devices to work is something that's really improving and increasing quite a lot today because there's been a trend, you know, people get more productive. Again, this is all business intelligence based on information that has been gathered. It has shown that bringing your own device programs have been known to increase productivity of companies by up to 34%. Okay. So 67% of employees use personal devices at work. Why don't you just encourage them to bring their own devices? People come with their cell phones, even their watches, and so on. You know, you can go ahead and use those to incorporate in your business. It might be a nightmare for security guys, but it's going to help you cut down on your cost. You know, people get more productive when they use their computers. You tell them, hey, bring your computer to work. You can use work from your computer, and that's fine. So you see now this Gartner is a big company that does all this statistical research. It has a prediction that by next year, 30% of IT organizations are going to extend their BYOD policy. That's going to include enhancements in your workforce, like smartwatches, for instance. So BYOD again has to do with bring your own device. Many companies out there now are, you know, using that. And, you know, this can be some of the smart questions that you can ask during an interview. You know, at the end of the interview, you know, do you have any questions? I'm like, okay, what's your BYOD policy of the company? That makes you look very smart because the manager might not even know. The manager will ask you, what do you mean by BYOD? Then you can boast. Like, do you bring your own device? Do you allow keyboards, mouses, or computers to be brought from home to use for work to improve on productivity? And then you can carry on from there. Sounds good? So that is BYOD. Next up is content management. So what is content? Content is
Are we?
whatever.
Do you think we'll go through all this
Yeah, not quite. So I'm going to run through most of them. Content management is very similar with customer relationship management. These are all management things, but what is content management? Content again is stuff that you use. Let's say, for instance, your website. Your website needs content, right? Oops, I think I went to the wrong one. Your website needs content. For that content to be utilized, you can have outsource it for someone else to do it. Now I'm using a word that I still have to define later on, okay? But before I get to that, let's talk about cloud computing. We talked about that very briefly anyway, but what is cloud computing? It's pretty much just using internet resources to run your business, right? So again, in a nutshell, the actual definition, you'd say it's delivering different services through the internet. It could be services like database, your network, your software, your servers, your storage. All those could be delivered from the cloud or the internet, all these different services. But then you can have it set up differently. You can have a private cloud, meaning only you in your institution has access to that cloud, okay? You can also have public cloud, in the case that you are sharing the same resources with others, but obviously it's demarcated. It's like you're renting from the person that's hosting it. In this public cloud, you could have providers, different providers. As you can see here, the major providers would be VMware, Google, Amazon Web Service, Microsoft Azure, Salesforce. So if you're using Google, then that is a public cloud, because Google has its servers that it's sharing multiple users to be using it. So you're just renting part of the space in there. The same with Amazon, the same with Microsoft Azure. And the other one is a hybrid cloud. Hybrid cloud, you could have, your private cloud in your own particular intranet, and also using some stuff in Google or Azure or AWS, okay? So when you combine the two, it becomes hybrid. There's another step also, which is known as multi-cloud. In this case, you can have some stuff in Google, you can have other stuff in AWS and other stuff in Azure, depending on what it is. Maybe it's machine learning. Machine learning might be good, and artificial intelligence on Google. And maybe the databases are better with Azure because you're also using databases from Microsoft at your parent company, so you want to integrate it that way. Maybe you want to use Amazon Web Services for Kubernetes or whatever it's known as containerized deployment of your application. So that would be known as multi-services, okay? So that said, let's jump into—
I have a question.
Yes,
For
go for
example,
it.
if you did cloud engineering using Amazon Web Services,
Yeah.
can you apply the same knowledge on Oracle?
Very good question. So it has to do, again, with understanding the fundamentals, okay? Once you understand the fundamentals, like we just talked about here, Oracle will also have all these different services that they are providing, okay? But it's just the terminology that might be different. It's just like, for instance, if you know how to drive a car, you probably know how to follow the same instructions to conduct a train. You can know how to ride a bicycle. You're just following the same procedures, but they might have different terminology, different meaning for each of those buttons. But in a big picture, you have to understand, is it a private cloud, a public cloud, or a hybrid cloud? Another thing that we didn't discuss here, but we did discuss it very in depth in the previous two classes when we talked about cloud computing, was the different types of levels, okay? Because again, with cloud computing, you're having different services provided on the cloud. So are you going to have your hardware on the cloud? That will be known as infrastructure as a service, which means everything that you develop, everything that you need, which is a storage, a hard disk, database, and so on, they are on there. Or are you going to have platform as a service? So it could be like, maybe I should be writing this down so that it makes more sense. And you can actually see what I'm typing. So it could be infrastructure as a service. That's the service that you're being provided, which is known as IaaS, meaning all your hardware is on the cloud. Or it could be platform as a service. What is a platform? Platform, let's think about things like operating systems. If you're going to be using the operating system that's not on your computer, but on the cloud, then it becomes platform as a service, okay? Maybe you're using Windows operating system on your computer, but you need a server that's using Linux operating system on the cloud, then fine, you can use platform as a service. Then all you do is you manage your data, you manage your infrastructure, your hardware, and then the cloud provider manages the platform and everything else. The next is application as a service, or should I say software as a service. Okay, with software as a service, everything is managed. Well, not everything. The software and the applications are managed by the cloud provider. You only have to take care of your own data, your users, your customers, and so on. Think about maybe Gmail. Nobody has their email saved on their computer. All your emails are saved on Google server, okay? All you're using is you don't download Gmail on your computer. You just go use a browser to be able to access it. So most of these use the browser and the web interface to be able to use it. So depending on all of that, all of these is the same terminology that you're going to see, but different implementation when it comes to whether it's AWS or Google Cloud Service or Microsoft Azure. So just understanding the fundamentals is usually the most important part. Once you got the fundamentals right, then you should be good to go with everything else. Sounds good?
Yes.
Awesome, awesome. So we talked about cloud. I think that was clear on cloud computing. Let's see, what else do I have? Content management and customer relationship management. Again, content, think about your website content. You can give somebody to build it and manage it. It's not only about creating the content, it's also updating it, managing it, and all of that. So again, oops. Let's see. All right. So that is, so yeah, content management, again, you're modifying it, creating it, managing it, and so on and so forth. All those things have to do with it. Deliver, develop, extend. It also includes deleting it, okay? So all of that reduces your own work, it reduces your maintenance cost and so on and so forth, because you have something else or someone else that's managing all of that for you, okay? So there are different types of content management software out there. For instance, you have Joomla, Magneto, Mambo, e-commerce, Drupal. WordPress is the most popular of all of them. Okay, so all these WordPress websites, all those stuff, they're being managed for you. That's their content. Now, the next one that we talked about was, I think it's a little bit lower, CRM. This is customer relationship management. So you have a business. Your business is, let's say, you're providing a particular product, or you're selling stuff, food, or selling anything online. With customer relationship management, you probably have a database documentation, the way you communicate, you build your customers, you have your promotions, interactions, and so on. You'll be able to integrate and manage all of those. You have your order system, you have your database, you have analysis. Based on all of this, you actually use marketing, sales, orders, and support to be able to run your entire business, okay? So if you hear someone talk about CRM, they're talking about customer relationship management, how you run your campaigns, how you manage your support cases. If they have issues, how do you fix them? If you're trying to sell things, how do you develop leads? How do you convert them and track opportunities? How do you deliver your products and produce your invoices and so on? So that's what CRM is about. CRM is about your relationship management, your sales, marketing, and so on and so forth. So that takes us back to, I'll probably go a little bit faster now. That takes us back to cross-platform. What is a platform? We talked about platform as a service just now. A platform could be many things, okay? We can start by talking about operating systems as platforms. If you're looking at operating systems as platforms, then you're looking at, is it Android operating system? Is it Windows? Is it Microsoft? Or it could even be Linux. Based on that, the operating system, you could also think about, is it mobile versus desktop? Are you going to be sending your software or your service or your product on a cell phone? Is it going to be portrait or is it going to be landscape? Is it going to be on a laptop or on a desktop? Is it going to be on a smart device or a wearable? So those are all differences of different platforms that we're looking at. If you're thinking of, building a website, for instance, are you going to build a website that's going to run on Edge or Chrome or Internet Explorer or Mozilla and so on? So those are the different examples of different platforms that we'll talk about, okay? So having a tool or software that is cross-platform, which tells you that, it can work on any platform, and it's usually a good thing that you need to have. Crowdsourcing is another trending IT term. Rather than you trying to develop many things, you go out and ask a crowd to help you with it. So there are communities out there that can develop stuff. If you want to create a website, for instance, okay, you need to get something done. Maybe you need to get a report created. All you do is you access top talent from around the world. The job gets done for a particular price. And this is very good for us in the IT field. When you pick a domain that you're good at, that you want to do, maybe cybersecurity, maybe web development, maybe software development as well. Somebody might reach out to you and say, hey, I would like to create a website. You tell them this is your price, you build it. You don't need to meet them. You just communicate with them over the internet and you get the job done. Like, hey, I need to create a report in Excel. How do I create this report? Can you help me with this? You say, okay, it's going to take me 2 hours to create a report. I'm going to charge you $50. Like, here's your $50. You get a report done. Boom, you send it to them. That's it. Okay. So crowdsourcing, again, there's a variety of different types of them. There's micro tags, there's macro tags, there's crowdfunding, there's contest, and so on and so forth. So those are different ways that you can get a crowd of people to help you with a task, and typically performed by a single individual, or you can have set up a group to get it done. Okay, sounds good? So sourcing, again, we're going to see that term. We talked about crowdsourcing. There's also open source. We talked about open source when we talked about, I can't remember, I think it was software and the hardware. But open source is very easy to remember. It's about your software that you develop. You're making it open for everybody to use. I think that's the very last thing I have on here. So let me scroll all the way to the bottom to be able to look at it. Yep. So OSI is what actually drives open source. Okay, OSI is open source initiative. Here they're just saying that your source code, your program that you've written, is going to be available for everybody free of charge. Okay. They have no limitations. They can use it for whatever. They can make changes to it. Derivatives are allowed. License must not depend on distribution format and so on and so forth. So I decided that I'm going to create a website and make it open source. Anybody can use that website, can make a copy of it, can modify it, maybe change the background, the color, and so on and so forth. That's what open source is about. I give you the source code. I give you the code that I created it with. You can modify it, change the name, change whatever you want to change. That's just fine. Okay. Data center, we talked about that when we talked about cloud computing. Data center is just a particular location, a geographical location where you save maybe your databases or your servers that do one thing or another. So let's see example here. I think I have a picture of one in here that makes you understand what it looks like, for instance. So this is an example of what a data center would look like, okay? But within this data center, you would have servers, with cables and so on that do one thing or another, okay? It could be a file server where files are saved. It could be a database server where databases are saved, web server, firewall server, and so on and so forth. So that's what a data center looks like. okay? And obviously Microsoft, Google, Amazon, they have a bunch of these out there. They have regions, they have multiple data centers in different areas, all right? Now that we've talked about data centers, let's talk a little bit more about cloud computing since we mentioned it. With data centers, you have something, and not only with data centers, with even cybersecurity, okay? Because with cybersecurity, we talked about the triad or the triad, CIA, which stands for confidentiality, integrity, and availability. So you want the data to be confidential. Only the person that needs to see it gets to see it. If it doesn't concern you, you should not be seeing it. You want it to have integrity. You want it to be true. Nobody has gone in and messed with it. If you're sending information that deposit 100 in my account, somebody should not go in there and say deposit 100 in John's account. Okay, so that's going to be integrity infringement. You want it to also be available. Based on this availability, if the system goes down, that's going to mess up cybersecurity, or one of the three facets of security. Also, you want to have data, I think I don't have it in here. Yeah, business continuity, okay? So disaster recovery could also be disaster recovery as a service, where you have this cloud computing or data centers that are helping you to recover your data. But what are some of the things that causes disaster recovery to be in need? Okay, there are many things that could happen to shut down your system. It could be the server has issues, or you could have human error. You input something and things go wrong. Maybe power outage, or some updates came in and they broke down the system, it crashed. Or it could be severe weather. Maybe there's a flood and it floods out this area, or maybe there's a thunderstorm or fire and so on and so forth. So all of those things may happen to affect one of these data centers or affect your computer itself. When that happens, you have to have a plan. You know, when you identify the resources that are connected, you check where there might be issues, you determine the impact when there's a disaster, and come up with a short-term and a long-term plan, and also test it. So for instance, if my computer is fried today, if I drop my computer, it breaks, how do I get all my information? I'm probably going to need all the information that's backed up on the internet, okay? So now when you say disaster recovery as a service, if your computer breaks or if your phone gets stolen, you're still going to have access to all your emails, because you don't need to build and manage a secondary site. There's no extra IT needed. It lowers your costs because all your data is stored on the cloud. So when you have disaster recovery as a service, it helps you build your business continuity. Your server is on the cloud, everything is on the cloud. If anything gets damaged at your particular location, you should still be able to pick up and move to another location and still run your business just normally. So that's what we talk about when we discuss disaster recovery and disaster recovery as a service, okay? So that said, the next thing is disruptive technology. We have disruptive technology. Again, just think about disruptive technology as something that changes the way that things are done or perceived. Okay, let's take a look at some of the examples, for instance. If you look at the way things were working before, oops, I'll move this again to another location. So before, if you needed to take a picture, you needed a digital camera, right? Today, you just have your cell phone and you're good. Before, if you needed to drive from one location to another, you needed a hardware, something they used to call TomToms, to be able to help you with directions, or maybe print out the directions from the internet. But today, you have Google Maps on your phone. Before, if you needed to find information about a particular thing, you need an encyclopedia. Today, you get onto Wikipedia, you get information that you need. If you needed movies, before you have to go to maybe Blockbuster or go to, I forgot what they call this in Cameroon, where you go and borrow Nigerian movies. Today, you get on Netflix, you see everything on there. Before, you had to call a taxi driver, maybe get on particular location to get their phone number and call a taxi or hail a taxi. But today you can use Uber and Lyft. So those are some of the disruptive technologies that, have taken place that have changed things. There are many more, before, if you want to send somebody a message, you have to go to the post office and send a letter. Today, you sit on your computer or on your phone and send an email. There are a lot of different things. These are all disruptive technologies that have taken place, okay? So what is disruptive technology per se? Let's go into the definitions itself. So disruptive technology, again, it refers to new technology that surprisingly displaces an already established one. It's as easy as that, okay? And next is enterprise architecture. Enterprise architecture, again, it just helps businesses find out how to implement best strategies in its development. So think about it as a blueprint. You have a blueprint for your business for it to succeed. And that's about it. Again, technology in the same light. Let's talk about, let's go to it. Is that the right one? No, it should be this one. So we've talked about disruptive technology and enterprise architecture. Next thing we talked about is, I haven't talked about IT governance, green technology. Green technology is really big, okay? And it also ties in with cloud computing. This is something that's going to skyrocket just like how the internet skyrocketed, because everybody is about saving the planet nowadays, okay? So what is green technology exactly? Green technology is, ongoing, or how can I say it? It's whatever you do in IT or computer science that aims in reducing our carbon print per se, okay? So looking at some of the situations out here, you'd see that instead of us having to set up your own server, set up all these things, you're going to need more resources. Instead, you can use cloud computing, which uses recycled materials. It reduces the amount of power that we're using, because I don't have to power my own software. The same power that's being used to power the software, or sorry, the hardware in the cloud or the data centers is being utilized for everybody that is using that data center, okay? Telecommunication is slow, visualization is utilized, and so on. So it reduces environmental problems, reduces energy consumption, reduces global warming. Ultimately, it saves cost. So it shows you again here the amount of the growth in billions, the potential businesses that is going to increase over time as we try to save our environment, save our planet, and save our lives. So it's carbon-free computing, solar computing, and quiet computing. So if you hear green IT, it's also known as, what's the other term that is being used for it? Safe IT or environmental IT, and so on and so forth, okay? So there's a lot of benefits, obviously. We talked about reducing costs and improves accuracy and so on, but that is for health IT, which we haven't talked about yet. But health IT as well, again, the same thing, technology. It has to do with healthcare in this case, in this particular case. So healthcare is something that's very vital in everybody's life. So being able to introduce IT in healthcare has helped us a lot, in case of increasing the speed, the accuracy. Imagine back in the days when you have to take your hospital book to the hospital. If there's no hospital book, you're in trouble, because the doctor is not going to know your medical history, right? If there's a flood or there's a fire or you misplace it, then they're going to have to start guessing or redo everything, which is going to reduce the accuracy, reduce the quality of your healthcare, increase the cost. It makes collaboration difficult. You can also move from one doctor to another doctor. All they have to do is just share your medical history and they should be on the same page, okay? So how does that help us, IT in health? You have a lot of different ways that IT is being used in health. It reduces the hard copies and paper We use it in imaging, registration, scheduling, billing, and so on and so forth. Okay. So those are very, very important things that we can use. It's also known as medical healthcare, you know, or digital healthcare rather, or digital medicine and so on. The next is the IT governance. IT governance has to do with disaster and risk recovery. It's usually known as GRC. GRC stands for governance, risk, and compliance. Okay. Risks and compliance. So it has to just go with, you know, if especially when you talk about financial institutions, you have to be able to meet particular standards. There are certain regulations that need to be met when you're dealing with people's data. You know, data, again, you have to make sure if you're collecting people's data, you're telling them how you intend to store it, how you intend to use it, and all those things. So that's what IT governance is about, okay? So making sure that people don't misuse your data or sell your data and so on. So it includes risk, audit, which is compliance, and security, okay? So some of the things, nope, I think that's going green. We already talked about that. ITIL is the next thing that we needed to talk about. And I really wanted to search this one so that you can see for yourselves what ITIL is. Okay. Meanwhile, do we have any questions? Any questions? No questions? Okay, let's carry on then. So ITIL, as we have seen, is a information library, okay? It talks about how different standards that we have to meet. You know, it's something that you can even take a certification for that to be able to go into any business or any organization that has IT department in it and help them to be able to produce a service design, service transition, and service operation to be able to generate their service strategy. So all of this has to make sure that you have continual improvements and so on and so forth, you know, which can be accessed by measuring, reporting, and improving all your systems. So you have a complete breakdown of all this ITIL framework on here that you can revisit. But in a nutshell, it's just different standards, okay? So as it says, it's a set of best practices and standards for improving your IT services. So people actually do take this certification and find positions in a company to help that company improve their best practices and their standards in their IT domain, okay? And I think we're almost at the end of everything we have here. Probably go for another 10 minutes or so. But if you have any questions, don't hesitate to ask, because I think we've covered almost everything here. We've talked about ITIL, we've talked about IT governance, and next we want to talk about visualization. So visualization, again, in this case, think about something that's virtual, that's not real, okay, that's not physical. So before you have your one computer, right? That one computer can only have one operating system. In order for you to be able to make sure that you can work with a server, multiple servers, you can go ahead and create a virtual server or a virtual machine within your computer. How do you do that? Just this one machine can be used to have several different machines. Maybe this machine will have a different operating system with this one and so on. So you can perform many things together. So traditionally, you have just your hardware. Your hardware has an operating system, say Windows or Linux. That operating system has different applications, okay? Let me make this a little bit bigger so we can see it clearly. So the hardware has different applications. Now, in a virtual architecture, what we know as virtualization, you have just that one machine or that one hardware. Again, that hardware we're talking about hard disk, storage, memory and so on, CPU that is being used. Now we add a virtual layer, known as a hypervisor. On that virtual layer, you can have separate operating systems. So this can be running Mac operating system, this can be running Windows operating system, and this can be running Linux operating system. So technically now you have 3 computers on one machine, which is what is being used extensively in cloud computing. Now I have to reduce this size. Okay, so virtualization is being used in the cloud because now you have your one machine, your one computer, you're able to connect to hardware that is being virtualized on the cloud. You can able to connect to another operating system on the cloud, you can connect to other servers and other storage and make your work a lot easier. So what is virtualization in a nutshell? Virtualization would be the development of virtual versions of IT resource. The IT resource could be a server, storage device, operating system, applications, and so on and so forth. So it just simulates that software and the hardware that allows it to run. All right. It helps us to be very, very extensible. It helps us to be scalable and so on and so forth. So instead of having multiple hardware, you have just one hardware that does all these different things for you. Okay. Finally, let's get to the end of, oops, I think I'm not clicking on the right one. There you go. Let's talk about artificial intelligence and machine learning. The artificial intelligence and machine learning. I said there were some words that I'm going to add in human factor in there. So think about artificial intelligence, human intelligence, machine learning, human learning. Those two are usually used interchangeably, but one is a subset of the other one, just like we talk about malware and viruses. So when you talk about, let's see, no, there we go. That always happens to me. I need to zoom into this side. So artificial intelligence, again, is a program that can sense, reason, or act and adapt. But then machine learning is a subset of artificial intelligence. I know there was a question asked earlier, what is an algorithm? An algorithm is just, steps of instructions or instructions in a particular step or in a particular sequence per se to do a particular thing. For instance, in arithmetic, in order to do long division, you have to do a particular series of steps. But in computer science, an algorithm is a series of instructions. So algorithms are used to improve performance and expose data over time using machine learning. So just like human learning, you know that if you put your hand on a hot pot, you're going to get burnt. Now you know not to do that. The next time, maybe you should get a cloth and hold the hot pot with a cloth so you don't get burnt. That's human learning. It's similar to machine learning. If machine learning gets a wrong answer, the next time it updates it and then it gets the right answer. But then with that, you can then develop artificial intelligence. You can have a program that is going to generate a robot. The robot knows that, okay, if I have to go through the door, I need a key to get through the door. If I go on the left, I'm going the wrong way. If I go on the right, I'm going the right way. So that program can then sense, reason, and act or adapt. We're not going to talk much about deep learning, but deep learning, again, is a subset of machine learning in which multi-layer neural networks are being learned with vast amount of data, as it mentions on here. So that's what we discuss about artificial intelligence and machine learning. You also have this available by these cloud providers. Google Cloud Platform has it, so you don't have to do everything with your own system because it uses a lot of resources. So you need those high resources. And the last three things, biometrics, everybody is familiar with biometrics. Wearables, these are just like smartwatches that we wear, all these other devices. So I'm not going to dedicate much time on wearables. GUI has to do with graphical user interface, okay? Graphical user interface. because everything that we're doing on this computer, what you're seeing here is a graphical user interface on this browser. But normally I can also do all these things on something that is known as CLI. CLI is the opposite of GUI. CLI is command line interface. So that's what most administrators spend their time on. So what's the difference between them? Graphical user interface just makes it easier for us to work because we can do all these things easily and we can see it. Command line interface is usually, black background, it has no color and so on and so forth, okay? So graphical user interface, you can see the software that you're using, you can see the operating system in this case. It's easy for you to use, it's easy to understand, it's attractive, but it's not as powerful as command line interface. The administrators have full access or good access, as we talked about, to be able to perform a lot more different tasks. Everything is available to you on the command line interface, but for the GUI, you can only do what is on the screen, what the buttons have given you, and so on and so forth, okay? And biometrics, we said everybody knows about biometrics. Biometrics is not necessarily just fingerprint. It could also be voice scan. It could be an eye scan or face scan and so on and so forth. There's a bunch of other ones out there. So those are some of the trending terms that we've covered. I think we've covered almost everything. I think we have covered everything that I plan to do so far. I'm not sure if you have any questions, any particular concerns that you'd like us to address. Now would be a good time for us to talk about those. Make sure you unmute yourself. You might be on mute. No questions, Delpy?
No. It's okay.
All right, Beatrice, you're also doing good?
Madam Ella, are you there?
That was fine.
Yes, I am.
Yeah, so can anybody share anything that they gathered today, anything that they think was interesting that they learned, or something that maybe they already knew and then they just got more? Let's start with Madam Ella.
Oh my God. Please, another person should just go on. Next time I will join, please.
Okay, let me just more light on the graphical user interface. Like we use the Excel, the sheet the graphical interface we are using. When you, for example, you want to do some calculation like 10 times 2, you just put the 10 times 2 and the results come out. The calculation is being done behind. The model does the calculation, you don't see where the calculation is being done. Then you just see it it's easy used and you see the answer. That's why it is called graphical user interface. The model of the Excel, where the program, where the algorithm is being written, you don't see it. That's the simple logic about it. You don't see where the calculation is being done. You see the figures, you just see the answer.
That's exactly correct. Exactly correct. Yes, that's why everybody likes graphical user interface. The prettier it is, the more colors, the more pictures.
Yeah.
It makes it more attractive and people use it more often. Many people get scared of using the terminal. The terminal, again, that's another word for command line interface or shell. Here I'm trying to open one, but you can always set it up to be a particular color. I can change the background.
This one, they'll run away from this one now.
And so on. So I can make it to have a different color. It might be green, it might be black, it might be whatever color. It depends on how you want it to look, okay? So again, basic color, green color, whatever color, if you want it to be, the homebrew version, and so on and so forth. Okay, so this is what the command line interface is. If I go in and say dir, or in this case, pwd, it prints my working directory. I'm currently in, maybe I should make this bigger. I'm currently under users v2dk, okay? And then I can do ls. It lists out all the folders that I have within my well, the subfolders within that folder. So if I go in here and open that, and I go into, where is it? Desktop, for instance. Ah, now it's thinking. Let's see. Under users, we can see that B2DK, these are all what is being shown in here. So you can see there's applications, documents, movies, public, applications, documents, movies, public, and so on. This is just command line interface. This is graphical user interface. This is nicer for most people use it, but administrators usually use this one to be able to do most of their work. So if I want to change and go into pictures directory, I can do CD pictures. And then it takes me into pictures directory. In here, all I have to do is just click on pictures directory, and you see that's what's in there. And if I do ls, it shows you photos library. That's what I see in here, photos library. So that's just the difference between command line interface and graphical user interface. Sounds good? All right, Ms. Anjo, what do you have to share with us? Anything that you have learned today? I think.
First, I'm not an adult. I'm just a teenage boy. So today I'll mostly learn more about the confused IT terms, which I already know, but I had a clear picture of what was it. And now for business, enterprise, business things that I learned mostly how many people, how they invest in their business, how firstly they try to gather first what are the things that the consumer like before now try to sell it. I mostly understood that part, and just that.
Good. Thank you very much for sharing. Yes. So again, it depends on which business, you can get hired for one business or another, just being able to, meet their business needs, depending on what role you're playing. Are you going to be a database administrator? Are you going to be a software developer? Are you going to be a data analyst, and so on and so forth? There are many different roles, like we did mention during our IT career paths, depending on what you really enjoy. You can decide whichever path you want to do. If you want to focus on hardware, software, web and internet services, networks, cybersecurity to make sure that there's confidentiality, integrity, and availability, databases, cloud computing, software programming, and so on, then there you go. All right, Beatrice, do you have anything else to add?
What really got me today was BYOD, bring your own device. That's something I've never really heard of, but which is practiced in where I work. Most of the time, we bring our personal computers, our personal devices to use to work together. So I did not know it had a name. So I've learned that.
Yes, that's really good. There are subtle things like that that people take for granted. And most people would tell you that BYOD is only bring your own computer. It's not only bringing your own laptop. It could be bringing your own keyboard. Where I work, many people, obviously they are geeks. Many people want their particular keyboard for one reason or another. Maybe the way the key sounds, maybe the way it feels, maybe the space it has, maybe it has some other features that others don't have, and so on. So BYOD is not only about bringing your computer, it can also be, using your own cell phone. For instance, I use my cell phone for work, which you can say is part of BYOD. Once you have the right security installed to be able to make sure that, hey, you do this. Some people have issues with that though, that, maybe they're going to be looking at your personal stuff, but obviously there are rules and there are governance, we talk about IT governance and other things that are in place to make sure that those things are not being used. So yes, BYOD is something that's really, really catching on. As you can see, more people are going to be using it. It helps the companies too. They don't have to spend too much money on getting new devices for new employees each time they have new employees or have old employees leave. But you have to also take care because security is a big thing. As soon as the person leaves the company, you have to make sure they don't have access anymore to that data because that's going to be breach of, serious security. All right, Del P, anything else to add?
Yeah, I think I have a question that's gonna help most of us here, especially I think Madam Ella. Now, for those who need some cloud space to store some of their data, for me, I use iCloud because I have Apple. And for those who are using the other computers, I don't know, what can they use?
Very, very good question.
Yeah.
So when you talk about iCloud, I would like to go, let's go into, let me go back to cloud computing that we did a couple weeks ago. Okay, iCloud was one of those that we talked about. So let's see if I have it in here. No, I don't have that. No. So let me go ahead and just write it down in here. So iCloud is what is known as, I mentioned earlier, software as a service, okay? Software as a service is for iCloud. So there are different types of software as a service. You said for those who need more storage and you use iCloud. iCloud is for Apple.
Yeah.
You also have Dropbox. Dropbox is something that you can also have. You also have Google Drive, obviously from Google, right? You have OneDrive. OneDrive is from Microsoft. So all those major companies have their ways that you can save data. So one quick way you can find out if you go in and do software as a service, and then you do storage types, you should be able to see a good number of them in there, okay? Normally, I go through the images. If you go through images, it might give you a good summary, of examples. So let's see. Oops, I should use examples, not types. All right, so here we are.
For Apple, I just have 5 gig free, and
Yeah.
I have there's an option of having 50 gig per month for $0.99 per month.
Yes, they have very different,
This is a question. The question is not, has not yet come.
Yes.
Now, for example, if I pay for a month or for a year, then the $0.9, the $1, $12 for a year, and it expired. So would I have access to that data anymore, or until I pay?
Okay, so it depends now on the particular rules of that company. If the company says you have access to your data, but you cannot add more data, you cannot modify the data, they might have different ways in which they want to set it up. Okay, does that make sense?
Okay.
Yeah, so that's where they'll trap you. One company would say, okay, you can have access to all your data, but you cannot add it, you cannot reduce it. Just like Google.
That means you cannot pick it up from there and put it somewhere and modify it?
You can pick it up from there and put it somewhere else. I think that should be good.
Yeah.
You can copy it. Again, it all depends. They might say you cannot copy it, but you can view it. Again, you have different access levels. You can have access just to read it, but not access to copy or write it and so on. So depending on the way it's provided to you. Okay. So yeah, as you can see, let's see, I really wanted to see, I'm not getting the examples that I wanted to see. The examples I'm getting are not what I was expecting. I think this might be a good example here. No, yeah, it doesn't have it. It doesn't have iCloud in there. So I don't think that would be a good example. But yeah, iCloud, Google Drive, OneDrive, those are all examples. I think I even had a list of them in here. SAS, types, examples. Okay. Yeah, this is a good one. No, it's not. But yeah, that's iCloud, as I said, Google Drive, OneDrive, and so on. Those are all examples of different iCloud as a different software as a service that you can use. And they all have their advantages and disadvantages based on what it is that you want to use. Like I said, where is my? Like I said, there are the three different models that we talked about. We talked about private cloud, right, where it's on your premises, public cloud, where you're using either Google, Amazon, and so on, and then hybrid, where you have both public and private. You also have multi-cloud. Most of us are using multi-cloud and we don't even know it. What do I mean by that? If you look at this example that we're looking at here, where is it? Where it's asking which one is better. This is an example of multi-cloud because most of you are using iCloud and you're also using OneDrive and you're also using Google Drive. That's an example of you having your data in 3 different places. You can decide that all your documents are going to go to Google Drive. All your business stuff is going to go to OneDrive and all your pictures are going to go to iCloud, and so on and so forth. So it's depending on whatever your use is, and so on and so forth. So here is an example of, the differences. The price here is free for OneDrive for 5 gigabytes, okay? If you're looking at Google Drive is free for up to 15 gigabytes. And if you're looking at iCloud is free for 5 gigabytes. So it's up to you how you want to do it. Now it has different types of plans now. If you want to pay this amount to get more data and so on and so forth, it's all dependent on you. So that's how you can go ahead and decide which one is best for you. Obviously, they work using the browser, so you can use any of those systems, Mac operating system, Windows or iOS, to get to whichever one. Okay, sounds good. Do we have any other questions? All right, so we started a little bit late. We started 10 minutes after the hour. It's 8 minutes after the hour. So at this juncture, I have to let you guys go, and then we're going to continue next week. Next week, we are going to talk in depth then on one of those that we just talked about, okay? So we're going to look at how you can get IT done, but I'm still undecided if I want to scratch this out so that we can go straight into using Microsoft Office products. And then we're also going to look at Google products, because I think these are some basic skills that will be good for us to look at, at least the different versions, the different products within the suite. For Microsoft, you have Word, you have Excel, and so on and so forth, Outlook, and so on. For Google, you have a bunch of other ones, obviously, just by going to, where is it? On here, you should be able to see the different Google options that you can see. Yeah, so if you go on here, you should be able to see documents, sheets, slides, forms, and so on and so forth. Sounds good? All right. Yes. So what questions do we have? Last call for questions before we call it a day.
Sounds good to me.
No questions? All right. Well, I wish you guys enjoy the rest of your weekend, and I'll catch on with you next week. Sounds good?
Thank you so much. Thank you. Thank you so much.
You're welcome. And the recording is going to be posted by the start of next week. So I'll send you guys a notification. All right. Enjoy your weekend and see you.
Thank you. You too. Bye.
Thank